All right, now let me show you something. Don't type anything, just watch. For the stack layout, I'm going to remove vertical options attribute. Let's run this application in Android and see what happens. Okay, this is what we get. Note that the box view is on top of the page, just below the blue bar. Now I'm going to run the same app in iOS. Okay, and this is what we get. Again, note where the box view is located. In Android, our page started right below the blue bar. But in iOS, our page starts right from top of the screen. So if we had some text here instead of box view, that text would clash with the current time. So this is one of the key differences between Android and iOS. In this video, I'm going to show you how to add some padding to top of the page, but only in iOS. So back in Xamarin Studio. In this video, I'm going to show you how to do this in Code Behind. And then in the next video, I'll teach you how to achieve the same thing in XAML. The reason I want to introduce you to Code Behind is so that you have better understanding of what happens under the hood. So we have this class called device. And this has a static property called OS, which is an enumeration of type target platform. So we can check if target platform is iOS. Then we set padding of the page, which we inherit from content page class, to a new thickness object. Thickness has a few different constructors, and the one I'm going to use now takes 4 arguments: left, top, right, and bottom. It's good to remember this order because you're going to use this a lot. So left 0, top 20, 0, and 0. So with iOS, we always want to add 20 pixels on top of our page, so the content of the page does not clash with the standard bar on top of the screen. Now, even though this code is perfectly fine, let's just assume we want to have different paddings for Android and Windows. So if you want to use the same technique, we would end up writing code like this: else if device.os equals target platform.android, something like this. Now don't worry about these numbers, these are just arbitrary. Now I want to show you a cleaner way to write the exact same code. This device class has a method called onPlatform. And this method has 2 overloads. One that is generic, as you see here, and the other that takes actions. I'm going to start with the generic one because it's easier to understand. So we supply the generic parameter. In this case, I want different thickness objects for different platforms. So the generic parameter is thickness. Now we can supply different thickness objects for different platforms. And to make the code cleaner, we can use named parameters in C#. So iOS, new thickness, also, you can see that thickness here is grayed out, so we can refactor this code and remove it. Now compare this code with what we wrote earlier. We don't have all this if, else, if, else, if. The code is cleaner and more focused. So internally, in this method onPlatform, we're actually going to have code like what you see on the top. So this method takes care of all these conditional statements and returns the proper thickness object based on the current operating system. So then we can get the result from this method and assign it to padding. We can use this onPlatform method with pretty much any objects. In this case, we are interested in thickness. In your applications, you might be interested on an integer being different across different platforms. Then you would supply 3 integer arguments. Now, as I explained earlier, this onPlatform method also has a non-generic overload. Let me show you how that one works. So device.onPlatform, I'm going to use the non-generic overload. You can see here we have 4 parameters, and they all are optional because they are set to null. So let's say I want to execute some code only on iOS. Then I can supply the name parameter here, iOS. And here I need to specify an action. So I'm going to use a lambda expression for that, like this. Now, if you're not sure what this all means, you really need to watch my C# Advanced course because I've talked a lot about lambda expressions and actions there. So here in this block, we can write the code that we want to be executed on iOS. For example, we can set padding to thickness object. This is another way to set the padding property. Also, for discussion's sake, let's say we want to have a different piece of code to be executed on Android. Then we set the name parameter, action, we use a lambda expression, and here we write the Android specific code. So this is how we use device.onPlatform method, whether the generic overload or the non-generic one. Now, as I explained before, we aim to use XAML to define the visual appearance of our applications. So in the next lecture, I'm going to show you how to use onPlatform in XAML.